everyone. We are Group 5 from CE14 Laboratory B2. Today we are doing the experiment of field density test by sand cone replacement method.
For this experiment, we will use sand cone, cylinder jar, scoop, ruler, weighing scale, and oven.
This experiment will help us determine the density of both sand and soil samples.
To calibrate the apparatus, begin by measuring the weight of each piece of equipment, such as the cylinder jar, sand cone, filter the sand and then carefully transfer it into the cylinder jar. Weigh the cylinder jar with the sand and repeat this process until all of the sand has been transferred. For the soil sample preparation, select a suitable location for obtaining a soil sample. Place the base plate securely on top of the soil surface and dig approximately 15 cm deep. Gather the excavated soil and transfer it onto a baking pan. Position the prepared sand cone apparatus over the base plate and ensure it covers the dug hole. Once the apparatus is properly positioned, unlock the apparatus to fill the hole with sand. Remove it after it has been filled with sand. Weigh the baking pan and measure its dimension. After putting the soil sample onto the baking pan, weigh it again and take note of its measurement. Pour the excess sand from the sand cone back into the cylinder jar with the leftover sand and weigh its mass. Transfer the baking pan containing the soil sample into an oven for drying. After allowing the soil sample to dry for 1 day, remove it from the oven and measure its weight accurately. These are the data that were gathered. Firstly, the mass of the cone, cylinder jar, sand, and the cylinder jar containing the sand. To get the volume of the cylinder, we filled up the cylinder jar with water up to the brim and weighed it again. The second table shows how the bulk density was determined. With the given mass, which is 4.8 kilograms, divided by the volume of the cylinder, which is 0.05 cubic meter to acquire its density. For the bulk density, divide the mass of the excavated soil, which is 2.02 kilogram, to the total volume, which gives us 404 kilograms per cubic meter. Table 3 shows how the mass of the soil sample was determined, which is through the subtraction of the mass of the container and soil sample from the mass of the container alone. To get the water content, subtract the mass of soil sample from the mass of dry soil sample, which results to 0.26. The last table shows the determination of dry density, which is by dividing the mass of dry soil sample to the total volume, which then shows the result of 352 kilograms per cubic meter. Based on the field density test conducted using the sand cone replacement method, we have calculated the moisture content and dry density to be roughly 12.87% and 352 kilograms per cubic meter, respectively. These are important variables that directly affect soil strength, soil compaction, and stability levels.